this point, we are now familiar with the concept of differentiation. Methods and rules used in this may simply be just a piece of cake for us now. That said, it is time for us to delve deeper into higher mathematics and start talking about integral calculus, starting from the basics. This is Angela Belle, and you are watching the basic rules of integration.
First and foremost, what is integration? Integration is the process of finding antiderivatives, which is basically the reverse of differentiation and its derivatives. It is composed of rules, which we will be tackling later on. Now, before we further proceed, we must know about what comprises of the terminology we just defined. So, what are the parts of integrals? The leftmost part, which is labeled as 1, is known as the integral sign. The middle part, labeled as 2, is known as the integrand. And lastly, the rightmost side, which is labeled as 3, is known as the variable of integration, which is simply known as differential. That said, we are now ready to learn about the basics of integration rules. Under integrals, we have the following rules, namely the indefinite integral of a constant, the power rule, the indefinite integral of a function, and the indefinite integral of the exponential function. With these are 4 formulas to aid us in our pursuit of solving integral problems. So, what are they? We have the indefinite integral of a constant, where the integral of k dx is equal to kx plus c, where k is the constant. Next, for the power rule, we have the integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1 plus c, where n is not equal to negative 1. Meanwhile, for the indefinite integral of the function, we have the integral of 1 over x dx is equal to ln x plus c, where x is not equal to 0. And lastly, for the indefinite integral of the exponential function, we have the integral of e raised to kx dx is equal to 1 over k e raised to kx plus c. Now, to further strengthen your knowledge on this topic, here are some examples which will utilize the given formulas earlier. Here are some examples for the indefinite integral of a constant. The integral of 7 dx is equal to 7x plus c. Now, why is that? When given a problem like this, one must find the constant, which is represented as k in the formula given. From here, we can immediately determine the answer, as 7 is our k. The same goes for the second example, where 1 over 2 is the constant. This will simply be equated to 1 over 2 x plus c. Now we have an example for the power rule. The integral of x raised to 6 dx is equal to x raised to 7 over 7 plus c. So, why is that? By simply substituting n, which is 6 in this example, to the formula above, we may now add all of this together, then directly add to c after simplifying. Next, we have an example for the indefinite integral of the function. The integral of 7 over x dx is equal to 7 ln x plus c. Needing to get 1 over x to be able to turn this into ln x, we simply take out the constant 7. leading us to get the 1 over x needed. From there, we can now convert this, thus leading us to the final answer. Last but not least, we have an example for the indefinite integral of the exponential function. The integral of e raised to 5x dx is equal to 1 over 5e raised to 5x plus c. Once again, upon finding the k in the equation, we can now substitute it as such, leading us to our final answer.
And that is all for today's lesson. I hope you've learned something new. Thank you for watching, and I'll see you next time.